So now we discuss the different professions that you might find in the engineering profession. And there are four broad engineering professions that you might find. The first one is civil engineering. We have chemical engineering. We have electrical engineering. And you have mechanical engineering. So these are the four broad engineering professions. And of course, as anything you might have found, there is always subcategories that you find, or some mixtures that or hybrid of either of these that you find on the ground or in the field. Like the most common hybrid is mechatronics, because mechatronics actually captures some elements of electrical and elements of mechanical, and you end up with mechatronics. But generally, it can be classified under mechanical engineering. Like if I just going in brief, I will talk about construction. Construction is under civil engineering, and in civil engineering, you are concerned with the structures, how buildings are going to bridges. Okay, bridges actually are the structural. And structural, sometimes they are somehow interrelated, because you'll find structures that require the ideas of structure. Buildings which are the construction that require the knowledge of structural engineering, etc. So these are the subgroups of civil engineering that are very closely related. And the other one is transportation engineering, particularly when you are seeing the design of roads. And again, even the plan, how the roads are going to be constructed. This is purely the work of civil engineering. So civil engineering, again, bridges also fall under the category of transportation engineering. But again, it's a sub branch. Then you have railway. Railway is also falls under the category of transportation engineering. But again, even in railway, you're still going to find electrical engineering coming in here, because most of the modern railway transport involves is electric. Therefore, electric transport or electric rail will require a lot of electrical engineering to be involved. Then there is geotechnical engineering, where you are going to find the likes of Kengen. I know some of you might have heard of Kengen. There is a lot of drilling. You are drilling under the ground, and you are going to be getting some gas trapped in here, and then it is channeled through a pipe, and then it is used to turn turbines and produce electricity. That is what Kengen does. So there is a lot of geotechnical involved there. But again, electrical engineering is also very much involved, because to generate electricity from this steam that is held underground is bulk of electrical engineering. There's also environmental engineering. Environmental engineering involves sewer lines and among many other things. So like sewers, some of you may know about sewer lines. You have heard of it. But sewer lines is under the branch of civil engineering, where they are designing how water is going to flow from buildings and pass through the drainage systems to the sewer treatment plants, etc. So that is a huge work that falls under the category of civil engineering. Then we talk about chemical engineering. And chemical engineering, there is biochemical, polymers, plastics, and food processing. And probably you might still find some other sub branches, but you can always know that the kind of producers of cooking fat, producers of the likes of Omo, soaps, etc. All of those fall under the category of chemical engineering. So that is another huge branch of engineering that is very useful in our day-to-day living. And also food processing. You will always find that a lot of foods are made from chemicals, and for you to produce those foods, you must have clear understanding of chemicals, and therefore you must follow the elements that we have defined above for you to be reliable engineer. Then there is mechanical engineering. I'm just introducing these concepts because they are important, and you don't want to fail to know how you as an engineer will relate with other engineers. That is why we always introduce you to these concepts of other engineering professions. So there is now the mechanical engineering. There is mechanical engineering in which some branches that are very useful, like fluid dynamics. You are dealing with how systems behave, particularly in terms of interaction with the fluids. And what comes to mind as I mentioned, mechanical engineers build machines, build systems, and you might find things like ships and cars, airplanes, etc. All of them are the work of mechanical engineering. So how, for instance, an aeroplane, so there is definitely some design that is involved here, because this airplane or this aeroplane is going to be interacting with air, and there is a lot of friction, and it needs to be able to float in air, for lack of a better word. So the plans on how these wings and this sharp front end and the flap at the back end are going to be interacting with air. There are so many mathematics involved there, and that is the work of fluid dynamics engineers. Then you talk about thermodynamics. This deals a lot with heat, and most of the machines generate heat, and therefore that heat needs to be managed, to be dissipated, and probably utilized for better uses. So in few words, and what comes to mind first and foremost is a car. In a car, there is an engine, and an engine operates in some ideal temperature, and then that temperature needs to be regulated, and for that reason you must manage that heat. So what you see is that a car engine is always cooled by some radiator, and therefore the design of such a radiator and how it manages that heat, purely that is work of mechanical engineer. And talk about mechanical design, there is a lot to do with gears. When you talk about gears, pulley systems, and you talk about hydraulic systems, I know you have seen the excavators and lifts. All this work involve a lot of machine design, which deals with gear system, hydraulic systems, and pulleys, and all that is work of mechanical engineering, or it is defined under the category or the subcategory of mechanical design. So in so many words, I have just told you what mechanical engineers does, and the subcategory of this. So the best example I can use to tell you the work that is primarily comes straightforward from mechatronics engineering is robotics. So robotics or robots or robot design is under the category of mechatronic engineering, because there is so much involved in terms of mechanical design. You need to design a mechanical system. It has gears, it has body, it has all those, it has wheels, etc. But still, it has a lot of electronic components, both electrical and electronic components. Therefore, it falls under the category of mechatronic engineering. So what you see in a robot, the ones that they can walk, they can drive, the robotic cars, etc., the robotic arms, all those fall under the category of mechatronic engineering. So having said that, we have first and foremost gone to the mainstream other engineering branches, like revolve around our engineering profession, which falls under the category of electrical engineering. And therefore, that is the one we are going to discuss next. But before we do that, I'm going to highlight that there is other engineering sub-branches that may not necessarily fall under the category of the three main ones. That is the industrial engineering, petroleum engineering, aerospace engineering, nuclear, bioengineering, and even mechatronics. So you can see mechatronics appears to be alone here, but again, as I mentioned, falls mainly under mechanical engineering and electrical. So industrial engineering, that is, these are the engineers who are involved in the industries. They are like a general purpose engineers who define what engineering ethics and tasks must be performed in an engineering ethical manner, without necessarily being an expert in either. So the industrial engineers are going to be the industries to assist other engineers or other designers to do the work that do. So having said that, of course, there's the work of aerospace, nuclear, that somehow you know them, but we don't have to go into the details. You can always read more on your own. But what we now want us to discuss in more details is the electrical engineering. And in electrical engineering, we have like many other branches, not just the four that are indicated here. But for the sake of this discussion, we can start with the four. We have power generation. That in power generation, we are involved with power generation. That is, how power is generated from hydroelectric power stations like Daruma, Masiga, among others. We can also have power generation from diesel, and there are a lot of private companies that generate power from diesel, and not now at the level of personal diesel engines, but even at the industrial level where we are going to be finding there are industries that rely purely on power that is generated from diesel power plants. So there are power plants that generate power. So that is the first aspect of power generation. In power, we have generation, and I've given examples of hydroelectric power plants. We have, that is one. We have diesel power plants. We have solar systems. We have wind generation of power. All this involves generating of power. That is producing power. But then after the power has been produced, there is that aspect of distribution. Now, before we do distribution, we talk about transmission. So transmission involves this, for Kenyan system, is done by Geotechnical. If you Google Geotechnical, you'll find a company or a government body that is charged with distributing power, and it is transmitting power from the source, from the generator, to the general area in which is going to be distributed now to the local user. So the word that we use here is when you talk about pylons, and I know you have seen them. Pylons are the long towers where very many transmission wires are hosted, or they are anchored so that they can be used to transmit power from probably Masiga. This might be Masiga power station to a substation. So this one might be a substation. So when power is being transmitted from the source to the substation, it is now from the substation power is distributed now from here. Substation is now distributed now amongst the users. So you might have now transformer here, transformer here, transformer here. Now we have now home state. This is a home. This is transformer. This is transformer. This is a substation. This is a transformer. So transformers, you have seen transformers in your neighborhoods. The one where people, some Kenyans are fond of being killed on these transformers when they are trying to tap power for themselves. So the transformers, I think, I presume you should know them. But if you don't know them, you can always Google a transformer, a power transformer. You will see them, and I think I'll show you this at a later images. But what I'm simply saying is that this aspect where power is now distributed from the substation to which is this one, to the transformers located in the neighborhoods of community, that is what is called distribution. So all that work is under the category of power system. So power systems involves generation, transmission, and distribution. And that is a whole field, the whole branch of electrical engineering. I will now talk about the other sub-branch of electrical engineering, which is communication. And in communication, we have communication systems, like I have said before, whereby we have, so in communication systems, we are going to be looking at these ones in more details later, but talk about wired systems. We have wireless systems. We even have fiber. And then this is like on its own. This is one is like its own. Here, this is where we have coaxial lines, and I think I have given you examples of coaxial lines before, and I've told you, like, if you talk about the TV area, this is the simplest example I can give. When it receives the signal from the air, there is a cable that connects, a white cable that connects the area from there to your TV. That cable is the one that is called coaxial line, and you cannot just use any wire to connect your TV area to your TV, because this coaxial line is specifically used to transmit some signals at a certain frequency. So for that reason, you are saying that kind of wiring, or that kind of cabling that is used for communicating is called wired. Another kind of wired system is the one that you use in your internet. We call them category 5. We have category 5 or cat 6. I think in the earlier days there were cat 4. Category 5 is therefore under the category of Ethernet cable or connector. I don't know what you should call them. So Ethernet is the one that connects computer. We have a computer here. to another computer. So this kind of a cable that connects that or via a router. I don't know if you have heard of these things, router or a switch. So the kind of connections they normally have. This kind of a wire has about 8 wires. So this kind of a cable is wired. It allows communication systems like computers, one personal computer, another personal computer, this is a router, communicate with one another, and somehow they connect you to the cloud. I know some of you might have heard of the word cloud. Cloud is the general internet that allows different computers communicate with one another, share resources among others. So this kind of a cable that connects internet or connect your computer to the internet or connect your computer to the router. This router can now be the one that is receiving internet from cloud, among others. This is the kind of a wide connection that is called Ethernet wire or Ethernet cable. So we have category 5 and category 6. We don't worry about this one now. We will know them later. They have different speeds, so we'll get to know them later. But now the broadest of category of communication systems that we deal with as telecommunication engineers is falls under the category of wireless systems. So in the wireless systems, we have satellite communication. Satellite communication, whereby you have satellites in the outer space of the Earth, and therefore they are so this is the Earth, and then we have satellites here. They are beaming signals to the Earth, and somehow when they do, you are receiving the signals. And one of the ways that I think might be very common for you to recognize is the DSTV. DSTV transmits signals via satellite. So they have the transmitting station here, sends the signals to the satellite, and then the satellite transmits the signal to you, the user. And for you, the user, you normally have a dish that receives the signals, and then this signal is received on the Earth, and you have your TV here, your DSTV signal. So that is one of them. The other one that is quite common here is the category of terrestrial wireless, and under the terrestrial communication is where we have the normal TV, both analog and digital TV signals. So I know most of you are conversant with the concept of digital TV signal. In the old days, I don't know how old you are, about 7 or 8 years ago, we used to receive signals purely on analog channels, and therefore this kind of terrestrial communication is work that is done purely by electrical engineers who have done telecommunication engineering. So if you want to find out where you will fall, you can actually know that you can do satellite communication among as many other communication systems that you have. Again, under the terrestrial communication, you will have what is called microwave communication. Terrestrial is also called radio communication. I think my board is getting full. Radio communication. They use radio frequencies. So we have I think I've already explained the concept of radio. Now there is another one called microwave. Microwave communications are normally used for communication, particularly when you talk about mobile phone communication. You guys have phones in your home, you are receiving some signals that are allowing you to communicate with me today. So that kind of mobile communication is using microwave frequencies, and there is a whole range of devices that communicate using such frequencies. So mobile communication falls under that category, and that is why I have given you as that example. So I don't want to dwell there over much. All I wanted to talk about is that a branch in electrical engineering that deals with communication is telecommunication, and there are many sub-branches of telecommunication, like I have mentioned, ranging from satellite. I think I also mentioned fiber in my introduction. I don't know where it is. So fiber is, I know you know about fiber. It's just that allows you to communicate one device to another using light. And I think there is a whole unit that you'll be introduced to the fiber communication, also called optical communication. So again, I think I have introduced that element of communication, or that branch of engineering, which is communication. The other one that I will introduce very briefly is the control system. So control engineering. Control engineering now allows you to control, like I think I mentioned that already. The idea of control, where you're talking about automatic cars. So automatic cars, they have a special gear system that detects when a car should change the gear from gear 1 to gear 2 or vice versa. So that kind of a control system is a work that is designed by electrical engineers so that the systems that are built knows where or what system or what state to change from one to the other. So we might have gear 1 to gear 2 to gear 4, I think all the way to gear 5 and back. So we can always transition from one system, and the automatic cars operate using such a control system. The other example that I can give you under the category of control engineering is that of lifts. Lifts are made such that you never really feel like a sudden change. Talk about sudden change when they are accelerating from stop to accelerate, and from acceleration to stop. So that is a very something you might have taken for granted. But what I will tell you is that there is a control system that like when the lift is stopping or the lift is starting, it stops very gently, and it starts very gently without you feeling like you have been dropped like a hot potato on the floor. So that kind of a system is managed by what is called a control system, or it is designed by a control engineer. So I just mentioned that for the sake of those who might not have a grasp of what that is. Again, I think I should give you one last example. One last example of control system is talk about a door. I don't know what it is called, but a door closer. I don't know what the name, but if you can just forgive me for lacking another word, I use this one. I know you have seen doors, particularly in the offices. Oh, sorry. There is a system that is normally put here that has some mechanism that when you release this door, it closes very slowly. That kind of a system that knows that now the door is open, it should close not very quickly but very slowly. There is some control system that is there, that is installed in this gadget that somehow manages that the door never bangs. That kind of system again is falls under the category of control system amongst many that have been designed. So having said that, I want to say talk about the last one, electronics. You know electronics without me talking about it too much. I talk about the radios, any electronic that you know falls under the category of electrical engineering or electrical and electronic engineering. That is a sub branch, and as a sub branch, you can be able to design electronics for different purposes, and they achieve different tasks. So I think that is one that requires at least introduction.